Welcome to Chem Mastery with Dr. Z. In this video, I'm going to talk about paper chromatography. So what is chromatography? Chromatography is a separation technique. So you could have a mixture of different substances and you can separate the component of the mixture using chromatography. In chromatography, we have two phases, something called the mobile phase, and we also have a stationary phase. So the mobile phase is basically a solvent which carries the soluble components of the mixture. And then the greater the solubility of the component in the solvent, the faster it will move through the stationary phase. The stationary phase will then slow down the movement of the components because the components will be attached to that stationary phase. And the stronger the interaction between the different components and the stationary phase, the slower the component will move. So we have different components that will move through the stationary phase with the help of the mobile phase. The speed at which they will move will depend on their interaction with both the mobile phase and the stationary phase. So basically, separation will be a result of the balance between the component interaction with both the stationary phase and the mobile phase. So what's paper chromatography? Paper chromatography is an analytical technique where different components can be separated based on their relative speed of movement in solvent as it spreads through paper. So the stationary phase here is going to be a paper. The mobile phase is going to be a certain solvent we are going to use. So the more soluble the substance in the solvent, the further it will move up through the paper, or the further it will travel up the paper. So an example of that is separation of different pigments in a colored substance. So in paper chromatography, what you need to do is that first of all, you need to have your paper, which is the stationary phase, and then you're going to have your solvent here inside a beaker. And then you need to cover the beaker, leave the solvent to equilibrate inside the beaker, and then your paper, which is outside, you're going to draw a line, and then at the bottom, this line here at the bottom, you're going to draw a line, and then you start to put the different spot. You could put a spot for the mixture, which is the a colored pigment, or a mixture of pigments like your ink. And then you're going to put some pure substances where each of these will have only one component. So like reference substances like A, B, C, and D. And then you will put your paper inside the beaker, but make sure that this line here, the bottom line that you draw, is above the level of the solvent, because if you put it inside the solvent, the different components will then dissolve in the solvent instead of moving up the paper. And then you leave your paper chromatography inside the beaker. Make sure that you don't just leave it for a few minutes, but you keep watching it, because what you need to do is to watch how far the solvent will travel in the on your paper. So there is something called the solvent front, which is the highest level of the solvent in your paper. So if you just leave it unattended for a few minutes, the solvent might overflow, then you will not be able to use it properly. As you can see, the different components will then be separated at different speeds, so they will give you colored spots at different distance from the beaker. The pure substances here, each of these will contain only one component. So A has only one component, B has only one, C, and D. So here, as we can see, there is the solvent level at the bottom, and there is the baseline, which has to be above, and then the different components which are going to travel at different speed. So what we do here and why this is important, because we can calculate what is called the RF value. So what is an RF value? The RF value is how far the different components have traveled. We calculate that by calculating how far the spot has traveled from the baseline divided by the travel of the solvent itself. So this is your solvent front here, and this is the baseline. So this is how far the solvent has traveled, and this is how far the spot has traveled. So RF value is the distance moved by spot over the distance moved by the solvent. RF value can be used to help identify each component. Why can we do this? This is because the RF value is not a fixed value. It actually differs depending on the solvent you use. So if you use the same stationary phase, the same substance, and the same mobile phase, you're going to have the same RF value for that substance. But if you change your solvent, you're going to have a different RF value. RF value can be used to identify compounds. This is due to the differing RF value. Substances can be identified by chromatography because that allows us to see the substance contained within a certain mixture or in a compound by comparing them to a reference value. So when you have a reference value for RF, then you can compare the RF value you obtained with the reference value, and then you can say that you have that particular substance in your component, in your mixture, or that your compound contains that particular substance. Also, substances which are not pure, which are a mixture, can create a series of spots. So when a chromatography is carried out on a mixture, the substances will be separated out to create series of spots. So each spot will represent a certain specific substance. Pure compounds produce only a single spot. So if you can see here, the first spot here is a mixture of three different components. Each component has been separated, but the remaining three spots each as a pure substance. So each one of these have created only one or a single spot. So you can identify whether your sample is a pure substance or a mixture of substances. And you can use the RF value to calculate the value of you calculate the nature or the type of your substance. In the description below, you're going to find a link for a video where I'm going to give you examples of how to calculate the RF value and also give you some exam questions from the GCSE exam board.